Hello everyone, I welcome you once again everyone to my digital platform. So let's start our today's discussion on basic logic gates. So we are going to study basic logic gates, but before that you need to understand what is logic gates. So in physics, whenever we are talking about this logic gates, a logic gates has one or more inputs but only one output. So whenever we are talking about this logic gates, the logic indicates a decision making process. A decision making process. That means if some condition will be satisfied, then only there will be output, otherwise there will be no output. So this if you want to explain the operation of the logic gates, we need to use Boolean algebra. So operation of the logic gates can be explained by using Boolean algebra. So this is a new term. What is Boolean algebra? So all of you know, every digital electronics is based on this algebra. This algebra only has two digits. And what are those two digits? 0 or 1. It can only read these two digits, 0 or 1. What does this 0 indicates? The 0 indicates off and 1 indicates on. Or you can say this 0 indicates no, 1 indicates yes. Or you can say this 0 indicates it's an open circuit, 1 indicates it's a closed circuit. So whenever we are going to apply this Boolean algebra in the logic gates, we can explain how the current is going to pass in the circuit, or current is going to flow in the circuit. So let us start our today's discussion on the basic logic gates. So whenever we will talk about the basic logic gates, we have three basic logic gates. So basic logic gates are of three types. The first one is OR gate. The second one is AND gate. And the third one is your NOT gate. So today we will especially learn what is OR gate. So this OR gate is a two-terminal device. That means it has two inputs but only one output. It has two inputs but only one output. And if you'll go on writing the truth table for it, that would be, since it has two inputs, so let us draw the truth table for it. Since it has two inputs, let us take one input is A, another input is B, and the output I am writing it as Y. So the Boolean algebra that this OR gate is going to satisfy is the plus sign. The plus sign is the Boolean symbol associated with this OR gate. So what should be my output then? This will be equals to A plus B. So what are the choices I have for the inputs? The choices I have for the input is 0 0, 0 1, 1 0, 1 1. So you add it by Boolean algebra. 0 Boolean symbol plus 0 will give you 0. 0 plus 1 will give you 1. 1 plus 0 will give you 1. And 1 plus 1 according to Boolean algebra will give you 1. So this is how the Boolean algebra is written. So now let us go and draw the circuit symbol to prove this OR gate. So this is your one of the switch 1. This is your second switch 2. They are connected in parallel with a resistor. Suppose this is a resistor. Then it is connected with a LED. So this is my LED. And then after that I will connect a battery over here. So this is my positive end of the LED. So that's why the positive end is connected to the positive terminal so that it would be forward biased. And this is my negative inside of the LED. So that has to be connected with negative terminal so that it would be forward biased. Now you see, this S1 and S2 act as two inputs, that is A and B. You see, whenever I am talking about 0 0, that means the switches are open. If the switches are open, you see the output is drawn across this LED. If the output is drawn across this LED, switches are open means the output is not going to glow. Whenever one of the switch is closed, the circuit is closed. That means if A is closed and B is open, so this one will be open circuit, but the current is going to flow in the upper one. That is your across this A. So we are going to get the output. If B is closed and A is open, then also the current is flowing in the lower half and we are getting the output. And if both are closed, then also we are going to get the output. So this is the circuit symbol for, or circuit diagram for measuring the output of this OR gate. So now let us do the circuit arrangement and check whether we are getting this type of truth table or not. So let's proceed. You can see here, this is the battery. This is the negative terminal of the battery and this is the positive terminal of the battery. So these are the, you can see here, these are the switches. These are the switches, and you can see here over the switches there are written 0 and 1. Here also 0 and 1. 0 and 1 means 0 means off, 1 means it's on, switched on. So here is the LED. This is a LED. This one is LED. Let me do the arrangement. So as I have told you, you see, these are the two switches, and according to the circuit diagram, here I have taken the two switches. These are the two switches. They are connected in parallel. You see, I have taken the two wires and I have arranged them in parallel. So the two ends of these switches according to the circuit diagram, is connected with positive end of the battery. So I have connected the terminal to the positive end of the battery. Then the other two ends here, this side, the other two ends are connected to in series with a resistor and a LED. So accordingly I have connected the LED and the resistor, and that terminal is connected with the negative end of the battery. So now that terminal is connected to the negative end of the battery. So what we have to confirm here, whenever the switches are open, you see here that the switches are S1 and S2 are just at the O1 or the 01 is pressed. So that means the switches are open. Means we are not getting any glow of the LED. You see here, there is no glow of the LED. Let me just arrange this one so that it would be visible. There is no glow of the LED. But second one is 01. That means I have chosen the upper one to be 0 and the lower one to be B. So let us choose the upper one to be my A and the lower one to be by me B. Then just switch it on. I have just pressed it. That means now it is on. The B1 is in 1. So you see the LED is glowing. So now if we will do the reverse one, that means the B is 0, A is on. You see the LED is glowing. And if both are on, that means both are at 1 and 1. Here in this case both are at 1 and 1. Then also the LED is glowing. So this is the experimental verification of the OR gate. I hope this is clear. That means if particular condition is satisfied, then only we are going to get a output. And when we are going to get the output? Whenever one of the terminal is high, or you can say one of the terminal is on, means we are going to get the output. And if both the terminals are off, then we are not going to get any output. So output is 0. So this is all about our today's discussion. Thank you everyone. Thank you for watching.